Okay, good afternoon guys. This meeting, ang topic natin would be Maxwell's equations. Okay, favorite ko tong Maxwell's equations. Pero recap muna tayo ng ginawa natin last time. Ang ginawa natin last time is we have started yung chapter 7, which is electrodynamics. Bale, anong mangyayari kapag ginalaw mo yung mga charges, ginalaw mo yung mga currents? Bale, hindi na sila constant right now. You have to accommodate for the change. And yung change na yun, nakita natin sa motional EMF, na pag yung changing flux, meron kang electromotive force na nakukuha. Okay? And then, after that, we have Faraday's law that says that changing magnetic fields induces an electric field. All right. Okay. So, Lenz's law would tell you kung ano yung direction ng induced EMF. And then, what else? Tinignan natin yung inductance, mutual inductance, and of course, the energy from magnetic fields. Okay? So, mahalagang learning from mutual inductance is that if you cannot get the flux from the other one, pwede mo siyang kunin sa kabila. Kasi yung mutual inductance, pwede mong pagpalit-palitin. Equal lang yung dalawang mutual inductance. Okay? So we have that. And then, what else? Ayan, self-inductance din. Pinag-aralan natin yan dahil kapag emit yung isang loop ng magnetic field, ibabalik niya rin yung sa sarili niya, and yung pagbabalik na yun, nag-i-induce din ng magnetic field. Nag-i-induce din ng EMF, I mean. Okay? Of course, from the self-inductance, meron ka nabubuong work or energy. And yung energy in magnetic fields would be similar to what we have obtained for the energy in electric fields. Ito, okay? So E squared yung sa magnetic field, electric field, and then sa magnetic field, you have your B squared integrated all over the volume bitaw. Okay? And then we proceed sa ating lesson today, which would be the Maxwell's equation. Okay, Maxwell's equation. Now, balikan natin yung maginawa natin, no? Before Maxwell, okay. Well, actually, itong mga equation na to ay gawa ni Maxwell. However, dahil nga sa mga experiment nila Ampere, nila Faraday, nila Gauss, meron tayong mga equation na alam natin before nung time ni Maxwell. Okay? So before Maxwell, you have this Gauss's law. Itong Gauss's law, again, nabanggit ko na to dati na this was just made from gravity. Kasi may Gauss's law for gravity. Parang naisip ni Gauss, pwede mo kuhanin yung gravitational field gamit ganitong formula, etc., etc. So si Maxwell, nire-write niya as this for electric fields, okay? And then the divergence of the magnetic field is zero. Wala siyang pangalan kasi parang purely purely experimental ang nakita niya. Since you have your magnets. You have your magnets like this, and is napansin mo na yung magnetic fields, it goes out and comes back. Goes out, comes back. And whenever you try to make a closed surface, a Gaussian surface, sabihin natin ganun, ang makukuha mo na flux or ang makukuha mo would be zero kasi lahat nung lumalabas, pumapasok din. So, nagka-cancel out yung dalawang yun. Zero siya. Okay? However, for dun sa charge mo, here, you have your charge. Enclose mo siya ngayon sa isang Gaussian surface. You'll see that the emitted fields does not come back at all. Okay? So, may na-measure kang value which is given by rho over epsilon. Yung rho yung charge distribution mo dun sa loob nung Gaussian surface. That's very nice, okay? And then, for Faraday, nakita ni Faraday na whenever you move things, you will change the magnetic field, meron kang lumalabas na electric field that is curling around your magnetic field. Okay, so we have this. And then, Ampere, nalaman niya na yung dalawang wire, whenever there are two wires, merong force sa dalawang wires na yun, and nakita niya na ayon ay purely magnetic in nature. So that is magnetic field due to currents. Kasi may wire siya, tapos meron kang magnetic field that attracts or repels the other magnetic fields. Gamit yung force na F is equal to Q V cross P. Okay? Okay, so we have that, no? So this is before Maxwell. However, let's parang na-bother si Maxwell dito. Si Maxwell kasi ay bibukid na gusto niya ng mahilig sa math to si Maxwell. Okay? So he likes solving things. Medyo hardcore siya Maraming prizes si Maxwell for in mathematics. Medyo addict tong si Maxwell when it comes to solving curls and divergences. Napansin niya ngayon na yung divergence ng isang curl, dapat yan laging zero. Okay? Nakita niya yan na dapat laging zero dapat yung divergence of a curl. Okay? So, let's try to get those divergences of curls. So, meron tayong dalawang curl. Kunin natin yung divergence na yan. Okay? So, unahin natin to number 3. The curl of E, kunin natin yung divergence yan. So, here you got your divergence. Diverge mo yung curl mo. Okay, so you have this del cross E, we know that, which is just Faraday's law, which is the change in magnetic field, negative. You have that. Kunin mo yung divergence. Si divergence ay geometric quantity, so hindi siya tatablan ng time. Okay, so papasok yung divergence mo dun sa KB. Okay. And we know del dot B. That's yung walang name. Okay. The divergence of a magnetic field is, of course, 0. And the divergence of a curl, whatever that is, 0 pa rin siya. And it checks out. Checks out, no? Nice. 0, 0. 0 is equal to 0. Okay. However, tingnan natin yung Ampere's law. Na-bother siya sa Ampere's law ngayon, tinignan niya. Tingnan natin yung divergence ng curl ng B. Okay. So, kapag ginawa mo yun, you will get the divergence of the J, yung current density mo. And we know that we have the continuity equation, which is this. Okay. However, we have said that in magnetostatics, del dot J is equal to 0. Since sabi nga natin, baliktad yung sabi natin that sa magnetostatics, the currents are steady. Hindi nagbabago yung currents mo. So, del dot J, hindi siya nagpa-pile up somewhere. Okay? Hindi naiipon yung current mo somewhere. It just flows uniformly along your circuit or along your wire or whatever that is. Okay? So, we have, it checks out naman, sir, na 0 dapat yung right-hand side and 0 dapat yung left-hand side. However, that is for magnetostatics. And in real life, magnetostatics is not always the case. Okay? Hindi lahat ng bagay gumagalaw. So, bihira yung cases na magnetostatics. Okay? In essence, hindi ito 0 yung right-hand side mo. So, na-bother dun si Maxwell, no? Bakit hindi 0 yung divergence of a curl? When mathematically, dapat pag kinuha mo to, dapat lagi yan 0. So, yung left-hand side mo, dapat lagi yan 0. Okay? So, hindi ito 0. Okay. Not 0 in general. Not 0 in general. Okay? Hindi nyo na lang sulat, guys. Okay. And one more thing. One more problem. Have you ever wondered kung bakit dumadalo yung current sa capacitor? Capacitor, di ba, may plate ka, but there's no wire inside. Di ba kayo nababother, guys, na nagmuni-muni kayo habang nagpapaantok? Meron akong circuit, tapos pag nilagyan ko ng capacitor, bakit nagpo-flow yung current? bakit dumadaloy dun yung current mo? Eh, wala namang wire dun. That is pure vacuum, di ba? So that is very, very, very weird. And if you try to use your Ampere's law, ano yung Ampere's law natin, guys? Del cross B, mu naught J, pero gamitin natin yung closed integral ng B dot dl. So ito yung integral form nun kanina. Gagamitan mo ng Stokes theorem para mapalabas to. And you find out that mu naught I enclosed. Okay? Sa libro, medyo nakakalito yung ginawa ni Griffith. So gawin natin in our own style. Okay. So we have your capacitor plates. Capacitor plates. Plate 1, plate 2. And then you have your wire, which is green. Which is green. Now, alam natin that we can always, since we know na tawag dito, magnetic field would curl around the current, syempre, intuitive sa atin na gumawa ng Amperian loop that would be circling around your current. Okay? So yan. Sabihin natin na yung current is flowing this way. Okay, para right-hand rule, madali yung Amperian loop natin. Of course, in this configuration, you would have your B.dl 2 pi s, tapos equal yan sa mu naught I enclosed, which is yung I mo would be this guy, I. Okay, so yung I na lang, yung I enclosed mo is just I. Okay, that's nice, that's nice. However, sabi ni Griffiths, kapag yung surface mo, ginawa mo siyang mukhang itlog. Okay, so medyo weird siya isipin, di ba? Kasi ang usual na surface natin na ginagawa or a loop would be looking at the current that is piercing through the area covered by the loop. However, mathematically, walang nagsasabi sa'yo nung gagawin mo isipin mo surface. Okay? So, pwede kang gumamit ng Amperian loop with this surface. Okay? Para sa chupon ng yung bottles ng pang-baby. Okay? So, parang chupon na ganun. Okay? So, pag ginawa mo yan, ano yung mu naught I enclosed mo? So, walang nagpi-pierce through dito sa surface na ito. Walang nagpi-pierce through. So, ang ma-enclose mo would be 0. 0 in that portion. Or, syempre, parang hirap naman niya isipin, sir, pwede ba kami gumawa ng Amperian loop na lang dito? Okay, pwede ka rin gumawa ng Amperian loop dito, no? Okay, pag gumawa ka ng Amperian loop dyan, 0. Kasi wala kang current enclosed. However, your circuit still flows. Okay? Kapag nagkabit ka ng ammeter dito, may mariread kang current. Siyempre nakakatakot, di ba? Parang, saan nanggagaling yung magic na current na yun? Kapag ginawa mo yung Amperian loop mo, wala ka naman makikitang current na nagpa-pass through doon sa Amperian loop mo. It's weird, right? Okay. So let's do this. Let's try to solve this conundrum by a math. Okay. Let's look at yung del dot J natin. Okay. Let's look at the continuity equation. So nakita lang to ni Maxwell kalikot niya sa math. Negative partial of rho partial of t. Okay? So it says that the change in the divergence of the current density is equal to the negative change in the charge density. Okay? However, the change in charge can also be a change in electric field, diba? So we can say that rho, validly, we can say that rho is equal to epsilon naught. Use your Gauss's law. Del dot E. So nothing prevents us from doing this. Tama ba? Okay. Okay. So ina-assume lang kasi dito na yung change in time would be of course change in just change in your charge. However, your charge produces electric field, so maybe we can use this not maybe, we can use this equation, di ba? From Gauss's law kasi this gives us the charge. So pag pinlog in natin doon, what do we get? Del dot J must be equal to negative partial T epsilon naught del dotted with T. Okay? And then geometric si divergence, so we can have something like this. Okay? Okay? Okay. So, pwede mo pang ilabas to para cute. Negative del dotted with epsilon naught partial of T, partial of T, and you have that. Okay? So, let's make it a vector dahil vector talaga yan. And lipat ko lang yung negative sign sa kabila. Negative del dot J. Okay. And then, del dotted with epsilon naught partial of E, partial of T. Okay. May nakikita na ba kayong something about here? So, this is negative del dot J. And if we are going back to what we have discovered, that del dotted with the curl of B must be 0. Pero ang nakukuha natin would be mu naught del dot J. Mu naught del dotted J. We have this. Ito hindi to 0. However, we can make it 0 by, of course, adding the same amount of del dot J. Tama, 0 to, di ba? Kasi mu naught del dot J minus mu naught del dot J, 0 talaga yan. However, ito nga yung naisip ni Maxwell na J can be purely current and J can be a purely field. Okay? Paano natin ito ililipat sa field? Balik tayo sa sinolve natin. Nakuha natin that del dot J is something like this. So negative del dot J is something like this. So let's write down. Ito, purely current ito. Ito naman, ilipat natin sa, so lipat ko yung plus, mu naught, negative del dot J. And this is what we have solved kanina. Itong negative del dot J, pwede natin siya ilipat in terms of electric field, which is this guy. Okay? So, mu naught del dot J. J plus mu naught del dotted with epsilon naught. Del dotted with epsilon naught partial of E, partial of T. Very nice. Ganda, di ba? Okay. So this makes your divergence of a curl become 0. And then if we're gonna revert back to yes, may tanong sa atin, bali pinilit niya po maging 0. Yes. Dahil addict nga si Maxwell sa math, alam niya na yung divergence ng curl, 0 yan kahit anong i-plug in mo na vector dito. Okay, kahit anong vector yan. Na-prove niya yun sa mga contest na sinalihan niya. Okay? Na kahit anong mangyari dapat 0 yan. So pinilit niya maging 0 by plugging in another term that is equal to the first term. However, inexpress niya itong pangalawang term as something different entity than charges or currents, I mean. Okay? In-express niya in terms of fields. So we have this guy. And if nirevert back natin to sa del cross B, tanggalin lang natin yung mga divergence. Okay, kuwari tanggalin natin yung divergence. Ang makukuha na natin would be mu naught J, okay, plus some additional term, mu naught epsilon naught, partial of E, partial of T. Okay. Ganda, di ba? So now, we have this extra term and kinuha niya, we have this modified. Ito na yung correction ng Ampere's law. So we have that second term. Tinawag ngayon to ni Maxwell na displacement current. And makikita natin that a changing electric field would induce a magnetic field. It's nice, no? Kasi parang incomplete yung sinabi ni Faraday na changing the magnetic field induces an electric field. But parang hirap naman pag tinignan mo in the other side. Pag nilipat mo yung point of view, dapat intuitively babaliktad lang din siya, di ba? So, ayun. It makes sense for Maxwell na gawin itong bagay nito. So, a changing electric field induces a magnetic field and we call this current as the displacement current. Okay? Bakit siya displacement current? Related siya sa displacement, electric displacement. Kaya siya tinawag na displacement current. Okay? So now, you can write the Ampere's law in a more cute na itsura. So del cross B would be equal na lang siya sa mu naught J, wherein yung J total. Okay? So yung J total mo would be the normal J and the displacement current. Okay? Displacement current. So, ayun yun. Kasi mu naught din to, di ba? Mu naught something. O kung i-express natin to as J, JD, it would look very nice. Okay? Okay. We have that. And now we go back to our capacitor problem. How does the current flow there? Okay. So, ngayon, alam na natin maiisip na natin na ito, may displacement current dito, kaya may dumadaloy na current. So, current siya na normal, pag tagos niya doon, magiging displacement current siya, and then, babalik siya as a normal current. Okay. Amazing, no? May gumagalaw na current kahit walang charge. So, yung current na yun is totally dependent of the field, electric field. Now we go back to the capacitor problem and we assume that the distance between them is very, very, very small. Okay, ganoon naman talaga yung mga capacitor, maninipis lang sila. And we know kapag meron tayong dalawang plates, alam natin na yung electric field due to a plate, a single plate, is sigma over 2 epsilon naught. And if yung plate mo, positive, negative, yung field mo is going from positive to negative, tapos dalawa yan kasi you have your from the positive galing dito, tapos negative galing dito. Tapos alam nyo na sigma over 2 epsilon yung kada isa. By superposition, you have your twice the sigma over 2 epsilon. Okay? So you have your sigma over epsilon. Okay. Very clear pa naman to, do? Dapat hindi pa natin siya nakakalimutan. So between the plates, meron tayong electric field. That would be 1 over epsilon naught, sigma. Yung sigma dito is charge density, no? Surface charge density. So if we're gonna express that in terms of the total charge, tapos yung area ng plates, we have this equation. Okay, clear pa naman, di ba? Kasi ito ay surface charge density, so charge divided by a surface, Q over A. Now, the change in E with respect to time would be the change in charges over time. Okay, kung isipin natin, mayroong mga charge na flow dito sa wires mo and magpa-pile up sila dito sa capacitor plates mo. Therefore, makukuha mo yung dq over dt. Okay? So, nag-change yung total charge mo doon sa plate with respect to time. Okay? And this change in charge with respect to time is just simply the current. Di ba? Kung ano yung current na nagpa-flow dun sa wire, of course, ganun lang din kabilis magpa-pile up yung kalakas magpa-pile. Kabilis or kalakas? Basta yun. Yung pag-pile up niya dito related with the current. So dq over dt is just the current. So we have partial of E, partial of T is equal to I over epsilon naught A. Then, pag ginawa na natin itong B.dl, try natin yung B.dl dito sa part na ito. Okay? Sa part na ito, sa may wire na, di ba? So, may wire, ang B.dl mo, B.dl is mu naught I enclosed, which is I. Tapos, 0 yung displacement current mo. Tama ba? Kasi walang sigma over epsilon dun sa part na yun. Diba? Sa part na to, sa wires na, wala nang electric field dyan. So we have that, you have this. And then if you're gonna do this for the portion na may space, for the portion na may space, ang mangyayari sa I enclosed sa normal current, B.dl would be 0 naman siya, tapos yung may term ay mu naught epsilon naught, and then partial of t dot dA. Okay, plug in natin yung this guy. Ay, mapansin nyo na mu naught, ay, tanggalin ko na yung 0. Pagulo na lang yan. Epsilon naught, ito ay I epsilon naught over A, I epsilon naught A, dA. Okay. May dot yan, pero kung similar yung direction no similar naman talaga yung direction ng current, pati yung dA na pipiliin mo. So, mawawala lang siya. And that dA is just yung total. Gagawa ka ng, sige, parang malinaw tayo. Nasaan yung problem natin? Yung dA na kukunin mo would be, of course, parallel to your plates. Okay? So, that dA is just A. So, cancel ito, mu naught I. Tapos, yung dA mo, A over A. Okay, may over A ka pa. Tapos, yung integral ng dA mo is just the plates. A. So, ano nangyari? Mu naught I. Okay. Amazing, no? Na yung displacement current will bridge down the real currents. Pekin current. Okay, so wala siyang discontinuity, no? Kaya pag tinignan natin yan sa mga circuits natin, kailan lang po present yung displacement current? Nagiging present ang displacement current when you have a changing electric field. Okay? So whenever you have a changing electric field, there is a displacement current. And that question is also posed by Faraday. Na hindi nakita ni Faraday ito dahil very, very, very weak ang displacement current. Compared mo sa total sa current na legit na current. Okay? So very very weak siya compared to that in usual systems. Kaya hindi ito na-detect agad ni Faraday. So namin niya ginawa in life, hindi niya na-detect yung displacement current. Okay? Amazing, no? So walang discontinuity yung current whenever you have this capacitor problem. Amazing. Kapag tinry niyo yan sa lab, tinignan niyo yung current dito sa pagitan ng capacitor, makukuha mo talaga na same lang siya sa current outside kung saan yung circuit mo. Grabe, amazing. Okay, we have that. Let's try another example. Okay, so imagine two concentric metal spherical shells. So meron kang shell sa loob, meron kang spherical din shell. Meron kang shell din sa labas, spherical din. Okay? So inner 1, radius A, meron siyang charge Q. Kalimutan na natin mag-Gauss's law. No? Ako. Meron kang charge, shell pala. Meron kang shell up to radius A. Then meron kang outer one na radius B. Yes. Ayan. Kunwari circle sila. Guys, huwag yung judge yung drawing ko. Radius B. Tapos si loob daw yung charge na, yung shell na nasa loob mo has positive Q. And the outside is negative Q. Okay, si Jello. Are you there, Jello?
Yes po, sir.
Anong electric field outside?
Electric field outside 0 po.
Okay, very good. Kasi yung charges mo, total charge enclosed 0, di ba? Okay. Total charge enclosed 0. At kung i-imagine ninyo yung electric field nito, yung electric field inside would be itong green outside, radially outward siya. Tapos yung electric field nitong outer shell would be inward kasi negative siya. Okay? And then wala siyang electric field inside, di ba? Kasi ganun lang naman yung ganun lang naman yung tawag dito. Nagagawa ng mga charges mo kapag enclosed sila. Wala silang pinaproduce inside. Okay, so we have that. Ang point of interest na lang natin would be the region between A and B. Kasi sa A, wala ding field kasi wala naman charge enclosed. Okay, so yung region between A and B yung interesado tayo. So sabi niya, the space between them, so region of between A and B, is filled with ohmic material of conductivity sigma. So we have a current flowing down, which is given by your Ohm's law. J is equal to sigma E. Okay, what is the electric field inside? That is very, very easy. E inside, yung sa inside A and B, no? So, E na lang, okay na yun. E is just by Gauss's law, 4 pi r squared, tama. Tapos, may Q enclosed over epsilon naught, r hat. Tama ba? Okay, for R, okay? Ay, sorry. Yan. So, between A and B yung R mo. So, you have this. So, the current that flows down in that region would be J, is equal to sigma times this guy. So, sigma 4 pi r squared Q over epsilon naught r hat. So, that is your current, J. Amazing, no? The current flows radially outward. And this, parang, wait lang. Tingnan natin, ano bang, yan. Basahin natin yung comments ni Griffith. The configuration is spherically symmetrical. So, the magnetic field has to be 0. Okay. The only direction it could possibly point is radial. However, the divergence of B must be 0. So, your B is equal to 0. And what I thought currents produce magnetic fields. Isn't that what Biesabart and Ampere taught us? How can there be a J with no accompanying B? Okay. So, ang problema ni Griffiths dito, bakit daw may current ka pero walang accompanying field? Kasi 'di ba alam natin pag may current tayong J, may umiikot sa kanya na tawag dito, na magnetic field. Okay. So, kung imaginein natin, no, kuwari we have a patch. We have a patch of the, kuwari ito equator. Ayan. Okay. Kuwari ito yung equator ng spherical shell. Equator. Itong green. Tapos, sabi sa atin na yung J mo is radially outward. So, we have currents that is pointing at us. Tama? So bakit nawawala yung magnetic field? Imagine natin, 'di ba magko-curl around yung magnetic field sa sa current mo. So we have this right-hand rule, right-hand rule, right-hand rule. Meron ka yung green natin is yung magnetic field. Okay? So kung titingnan natin, itong part na to, magka-cancel siya with dito. Itong part na to, magka-cancel siya, baliktad pala. Yung part na to, magka-cancel siya with dito. And then, for this part, sa left hand, ito, magka-cancel siya dito and so on and so forth. Dito, dito, cancel. Okay? So, nakikita nyo na bakit nawawala yung field. Okay. So, ito yung intuitive way of thinking it. And if you like math, it simply tells us that if the magnetic field has to be radial, del dot B is equal to 0, wala din makukuhang field. Okay, so math, ito yun. Ito yung intuitive. So, paano yun? Okay. Bakit ganun? Unang-una sa lahat, yung B of R ay an Ampere's law. Hindi sila varying with time. Hindi sila varying with time. So, hindi natin pwedeng i-generalize na for this part, the current would produce magnetic fields. However, parang hindi convincing yung part na yun, di ba? So, let's try yung paggamit ng displacement current. So, the displacement current would be partial of E, partial of T. So, JD, kunin natin si JD. Okay, epsilon naught. So, epsilon naught, JD. Tingnan natin kung anong mangyayari sa displacement current. Partial of T, partial of T. We know E, sorry. Epsilon naught, partial T. Plug in lang natin itong electric field natin, which is we have this guy. So 1 over 4 pi epsilon r squared, sorry, but r cubed. Tapos q over epsilon naught. Cancel. And yung mangyayari lang, yung maapektuhan lang nung derivative is yung q mo. Okay, magiging current siya. So 1 over 4 pi r squared, tapos dq over dt. And this is I over 4 pi r squared. Okay? Teka lang. Tingnan ko lang kung tama yung... Tama yung ginawa natin. Okay, tama tayo. So this is your displacement current, but what is its direction? So you have your... gawin na lang natin tong Q dot, sorry. Q dot. Okay? 4 pi r squared. Okay. We have this. Tapos, we go back here. Kasi alam natin na yung J mo, how did we know po pala that Sir Q changes with time? Definitely, definitely hindi mag-change yung arm mo. Tama ba? Okay? Alam natin na nag-change yung Q with time kasi we are in a space that is filled with ohmic material, so we know that a current flows. Okay? Okay. Okay, so kuha ba yan? Okay. Sige, sige. Ito pala yung ito yung current density natin. Kunin natin ngayon yung total current, which is I, para makita natin yung kunin din natin yung total current for your electric displacement current. Diba? Kasi JD pa lang itong mga J pa lang kinuha natin. So your J dot dA for your total current. Okay? And if we're gonna use the continuity equation, lagay ko lang din yung continuity equation, that would be negative partial of Q with respect to T. Okay? Okay. So yung lumalabas na current is nababawas na charges sa loob. Okay. Continuity equation lang. Pero ito naman yung mahalaga sa atin. So J.dA is very easy kasi yung J mo radial na siya, and if we're gonna pick a radial surface, that would be a spherical shell then. So you have your, papihin lang natin to. Sigma Q 4 pi r squared epsilon naught. Sigma Q over 4 pi r squared epsilon naught. And easily, dA na to. Tapos 4 pi r squared din yung area na yan. So the current that is flowing from the inner to outer 4 pi r squared, cancel. Okay, so yung current na nagpo-flow, current I is actually sigma Q over epsilon naught. So this is your current that is flowing from your inner to outer shell. Which makes sense, di ba? Na inner to outer siya kasi positive yung inner mo, tapos negative yung outer mo. Okay, so papalabas siya. And then, if we're gonna look at this guy, yung nababawas na charge would be negative of the current. Okay, which makes sense kasi, di ba, pag dumadalo yung current mo, nababawasan yung charge dun sa loob, sa inner one. So we have this. So JD is just, kung gagamitin natin itong change in current, ang plug in natin would be negative I. Negative I over 4 pi r squared. And then the total current would be JD divided with dA. And then this is very intuitive kasi negative I over 4 pi r squared times yung integral ng dA would be, dA would be just simply 4 pi r squared lang din, 4 pi r squared, and this cancels out. So yung displacement current mo is just the negative of pi. Okay? It cancels out. Kaya walang magnetic field na nabubuo kasi nagkakina-cancel yung displacement current yung current mo. Okay. So, question, is this setup feasible? Hindi mo siya magagawa. Okay? So how can you have your parang ang hirap isipin na magkaroon ng isang radial na current, no? So sa center niya, out of nothing, may lumalabas na current. Kaya weird. Okay? Kaya ayun. The displacement current will actually help in solving that problem. Now we have the legit Maxwell's equations. So now we have your Gauss's law unchanged, and then the no name na law. Okay. And then Faraday's Then, of course, Ampere's law with the Maxwell's correction. So you have this equation number 4, wherein the additional term is added, the displacement current. Okay? And si Griffiths, ayaw niya na tong notation na to. Well, ang gagawin niya lang naman is to transfer some terms into to the other side. So, ang gusto niyang representation ng mga equation niya, ganito. Okay? Sa left-hand side niya, nilagay niya lahat ng fields. At yung electric field, magnetic, it's all on the left side. And on the right side would be the charges and the currents. Okay, galing, no? It tells you na whenever you change whenever you adjust your charge and the current, meron apektado yung electric field and the magnetic field. Okay, in this special case lang nga lang dito sa number 3 and 4 is that yung B and E would influence each other. Okay? Sa Gauss's law, it's the charge, only charge influences the electric field. Okay? Ang galing, no? Kung mula dito, tingnan nyo left-hand side, divergence, tapos constant sa labas. Left-hand side, divergent, constant sa labas. Okay? Tingnan nyo dito, first term may curl, second term may partial derivative with respect to time. And this number 4 equation, mayroon kang curl and then mayroon kang term na dependent on time. So what if hindi zero to, no? Ang ganda sana. Ang ganda sana ng Maxwell equation kung hindi zero tong dalawang to. And we say na, paano kung meron tayong magnetic charge, which is non-existent, guys. No? Ang ganda lang kasi na, if they were literally symmetric, we have this equation. Okay? So kung wari meron tayong sinabing magnetic charge, rho m, yung rho e would be your electric charges. Paano kung meron tayong magnetic charge? It would be like this for the number 2 equation. For the number 3 equation, meron tayong tinatawag na magnetic, yung magnetic current mo. That would be yung current na due to magnetic charges, and it would look very, very, very nice. Tingnan mo yung pattern. Diba? Ganda. And then, of course, yung magnetic charge and the magnetic currents would be bound by this continuity equation, which is very similar, actually equivalent or similar to your continuity equation for electric charge and electric currents. It's it's O. Okay. So yung Maxwell's equation, it begs for the magnetic charge to exist. However, parang ayaw ng Diyos yun. Sabi nga ni Griffiths, God didn't make magnetic charges. So wala. Zero tong rho m. So far in our existence. Zero yung rho m. Therefore, pag walang rho m, wala kang Jm. Okay, so we have this. So huwag nyo itong gagamitin, wala talaga to. Ito yung ito yung legit mo. Okay? Okay, ayan. So wala lang, to, side comments lang ni Griffiths to na ang ganda sana pag meron tayong magnetic charge. Okay? Sila Ampere ang isip nila ang iniisip nila merong magnetic charge. Pero so far, wala tayong nakikita. Okay? Now, tingnan natin how your Maxwell's equation would look in matter. Okay? Paano kung nasa matter to? Parang mas maganda na isulat to in terms of yung mga electric displacement mo and auxiliary field H. Okay? Kasi hindi naman laging simple yung tanong. Laging minsan may matter. So mas maganda na alam natin din yung Maxwell's equations in matter. Okay, so let's go. And we have another topic, so polarization current. Ano ba yan? Dami namang current. So we have the bound charges, rho B. Diba? Kung naalala nyo, which is just the negative divergence of the polarization. And JB, the bound current, would be the curl of the magnetization. Okay? Now, we suppose that, di ba, kung isipin natin, we have, kunyari, meron tayong cylindrical item. So, cylindrical. Okay. And you blast it out with a field. You blast it with some electric field. And what happens when you do this? Nagkakaroon ka ng polarization. Tama ba? So, yung mga charges mo would follow the directions of the electric field accordingly. Okay, so yung positive, susunod sa electric field, negative. So, pupunta siya sa against the electric field. Okay? And when you change pag may ganito ka na, meron ka ng quantity na P. Okay? So, you have your polarization quantity. However, if your electric field increases, tataas din yung P mo. Okay? So tataas yung P mo. Okay? Mataas yung P, and what happens? Meron kang something that lumalaki na papunta dun. So kapag gumalaw yung charges, yung mga bound charges mo, may current na actually nabubuo. So we call that the polarization current. Okay? That is due to the changing polarization. And yung polarization mo is directly related to the field. Okay, so you have that. So whenever you have your changing polarization, may extra current sa loob ng material, and we call that the polarization current. Okay? And nicely enough, if we are gonna get the divergence of this J, yung JP mo, JP. So you have this. Kung defined as this yung JP mo, the polarization current as the change of polarization with respect to time, then you have this. Papasok lang yung divergence kasi geometric quantity to, no? Pinasok mo dyan, del dot P. You know del dot P, diba? Ito yun. Yung bound charges natin. Defined ganito siya. Amazingly, it would fit perfectly to this guy. Okay, and if you look at this is your continuity equation, and you see that the polarization current is following your continuity equation. Nicely enough. Del dot J P is equal to negative rho change in time over P. Okay. Nice. So we have your charges and your currents. So for the charges, we have your free charges, rho F, and the bound charges, rho B. Okay? And we have your currents naman. Total currents would be 3 terms na. Di ba? Dati 2 terms lang. Ngayon, 3 terms na. So you have your free currents, the bound currents, and the polarization current. Last time, hindi natin to nakita kasi hindi naman nagbabago yung polarization natin. So, the change of P with respect to time is just 0 sa mga una nating kinonsider na problems. Okay? Ganda, di ba? So, ngayon we have that extra term. So, that's your total current. This is your total charge. Densities. Okay, mga densities yung tinutukoy ko, guys. Feel ko gets naman natin yun. And we have to revisit, of course, our Maxwell's equations, kung saan may rho at kung saan may J. Okay, so wala tayong paki sa number 2 at 3 dahil wala silang rho at J. Okay. So going back, we revisit Gauss's law in matter. So you have del dot E is just your rho over epsilon naught. And rho, we have expanded it now as 2 terms, which is rho F minus the divergence of P. So 1 over epsilon naught, rho F, and then minus del dot capital P. Okay? So you have this, and kung naalala natin na yung P, itong relation na to, we have, pwede nating ilipat. Okay. So, lipat ko yung term na to on the left-hand side. P plus 1 over epsilon naught del dot P. Tama ba? And on the right side, yung naiwan na lang, 1 over. Okay? Okay, we have this. And then, since pwede natin factor out yung divergence, we have del multiplyan ko lahat ng multiplyan ko lahat ng epsilon naught. So this is your, actually pasok ko na lang epsilon naught. Plus E. Okay, makes sense, di ba? Pag binalik ko yung divergence, I get back to this. Equal to rho F. Multiply ako ng epsilon naught, okay? Para cute. So we know this term, which is the dielectric displacement. So you have del dot D is just rho F. Okay? So this is your Gauss's law in matter. Next, Ampere's law in matter would be del cross B. Then mu naught J. However, J is now 3 terms. J is now 3 terms. Balik tayo. JF plus JB plus JP. Okay, so we have JF as is. JB is just the curl of M. And JP is just the partial of P with respect to T. Okay, so we write those things down. JF. Tapos, plus del cross M. Plus partial of P with respect to T. We have this. And then, of course, the correction term, huwag natin kalimutan. Plus mu naught, epsilon naught, partial of P, partial of P. Plus mu naught, partial of P. Lalagay ko to sa loob. Okay. Para cute. Lalabas lang din naman yan mamaya kasi constant lang siya with respect to time. Okay? Lipat ko yung... Divide ko everything by mu naught. So, and then lipat ko lahat ng curl sa kabila. So, B over mu naught must be equal to JF. Oops, sorry. Nilipat ko nga pala sa kabila yung minus del cross M. Wala na siyang mu naught kasi dinivide ko nga everything by mu naught. And then, JF na lang din kasi divided by mu naught na lahat. Plus JP. JP pala. JP pa rin naman ito. Plus partial of P. Okay. May question tayo. Sir, ano po ulit yung del cross M? Yung del cross M ay yung bound current na diniscuss natin last time. Ito yan. Del cross M. JB siya. Okay? So, ang total current kasi natin, JF plus JB plus JP. So, JF plus JB plus JP. Okay? Okay, we have that. Nasagot ko ba yung tanong mo? Sorry. And then now we have your auxiliary field H as defined as 1 over mu naught P minus M. Okay, 1 over mu naught B minus M. So I can factor out the curl. So you have this mu naught M. Mu naught B pala, sorry. And then JF plus, factor out ko yung partial with respect to T. And this is just epsilon naught P plus P. Okay? And nicely enough, this is your auxiliary field H. Dinefine natin yan dati sa chapter 6. So we have del cross H. And then the right-hand side would be JF still. Tapos plus partial of with respect to T. And we know this, that is just your electric displacement. D, okay? So you have this expression, del cross H, the curl of H is just the free currents plus the change in displacement, electric displacement. Kaya tinatawag na displacement current. Okay? Ito yun. Kasi galing siya sa electric displacement. Kahit pangit yung pangalan ng electric displacement, ginamit pa rin siya. Sige. Okay? So, ayun, doon lang nanggaling yung displacement current. Kasi itong term na to, ayun yung displacement current and in-express siya sa electric displacement. Okay? Ito kasing Maxwell's law, Maxwell's equations in matter, ito yung gamit na gamit lalo na sa labs. Okay? Ito yung mas ginagamit ng mga equations. Dahil sa lab, hindi naman laging in free space yung mga fields mo. Okay? So this guy is equivalent to this guy. Yung kanina nating Maxwell's equation. Okay? There's nothing, there's nothing, walang superior sa kanila. You can use the other one and you can use this guy. This is a matter of convenience in writing. Okay? Dito rekta ka na sa mga auxiliary fields and displacement, electric displacement. However, you have to redefine yung mga terms mo. You have your magnetization, you have your polarization. So marami ka pang extrang definition, di ba? Ayun yung trade-off. Doon, rekta ka na sa 4 lang na equation. So kaya walang superior sa kanila. Pwede mo silang gamitin either way. Depende sa need mo. Okay, so we have this, Maxwell's equations in matter. And then, of course, yung mahalaga sa atin, yung saan yung intuitive sa atin would be the Maxwell's equation in matter in integral form. Okay, so ito yung mga ginagawa natin na shortcut para mapadali buhay natin. Diba? Kuwari, example nito would be D times, kuwari spherical yung setup mo. You know that you'll be using a spherical Gaussian surface and then QF enclosed. Simple enough, makukuha mo na yung electric displacement as R hat. O, diba? Dali. Again, guys, yung left-hand side would be always variable. Okay? Okay. And then, ayan, ito yung other definition. You have your Ampere's law. Okay? Ampere's law. Which is, kaya nyo na yan, guys. Okay? So, may nalagdag lang would be the different, yung Ampere's law dati, mu not I lang, di ba? Pero ngayon, may nalagdag lang. Nagbigay na tayo ng example nito last time. For the flux, pwede mong gamitin yung E.dl. Okay? D.dA, madali lang din yan. Flux lang. Itong mga terms na to ay flux lang. Okay? Pag sinabi kong flux, that would be of a vector. Integral of a vector times yung some area that the vector is passing through. Okay? And then, of course, to check things, you have your boundary conditions. And also, this boundary conditions is very helpful for your Laplace equation. Nag-Laplace equation ulit kayo sa di ba? Sa exam, nung last exam. So, nakabawi ba? Nasagutan nyo ba yung mga bagay-bagay? Redemption arc, di ba? Umulit lang yung mga tanong. So, for third exam, di na uulit ang mga tanong kasi bagong thing na itong mga to. Okay, so you have this boundary condition. Siyempre, you want to express this again in easier terms. So you have your boundary conditions for linear media. You have this, epsilon 1, epsilon 2, kung ano yung mga permittivity ng materials mo from one side to the other side, and then you have your mu1 and mu2 for your permeability ng mga materials mo. Okay? As usual, ganun pa rin yung perpendicular ng magnetic field, wala siyang discontinuity. Marami po palang equations. Yung Maxwell's equation, guys, hindi lang 4 yan. Pag binasa niyo yung libro ni Maxwell, napakadami na. Buong libro, puro equation. Okay. Pero in essence, kailangan mo lang yung 4 na yan to solve for things. Okay? And then for number 3, you have your parallel component of the electric field for any surface na walang discontinuity doon. However, ito na yung mga discontinuity. Okay. And then nicely enough, if there are no free charges or currents at the interface, wala kang free current and free charges, ibig sabihin, mag-zero out lang yung mga right-hand side nilang lahat. Okay, so the discontinuity now lies as the yung difference nila in the properties of the material. Okay, etong mga equation na to, 1, 2, 3, 4, would be very helpful in theory of reflection and refraction. So mula dito, ito yung fundamental basis ng Snell's law. Okay, yung sin theta 1, sin n1, sin theta 1 is equal to sin n2, sin theta 2. Okay, so ano to, scam na law to. So hindi nga alam kung galing nga kay Snell, kung sino man si Snell. Okay, so yung fundamental theory dito would be depending on these 4 equations. Okay? 4 equations. Galing. Makikita natin yan. Now, let's look at the, nakita na natin yung di ba, Maxwell's equations in matter. Now, let's look at the very special case of the Maxwell's equations being in equations to. Diba yan? Equations in vacuum. Okay, so what happens when in vacuum? Ano yung titignan natin? Balik tayo dun sa unang definition natin ng Maxwell's equations. Okay? In vacuum, Ross, anong mangyayari sa Rho?
Sir, in vacuum po, sir?
In vacuum.
Sir, 0.
Okay, tama. Walang charge sa vacuum. Tama. Okay. Sa Lance, ano mangyayari sa current mo in vacuum?
0 din.
Okay, kasi walang current sa vacuum. Diba? Very naman yun, very intuitive. So you have this to be 0 in vacuum. So let's go. What can we obtain from that? This is one of my favorite topics in physics. Tapos ito rin yung demo lecture ko nung pumasok ako dito sa UP Manila. Okay, so in vacuum, we have this equations dahil sabi nga natin, there is no charge in vacuum and there is no current in vacuum. So this is 0. And you have these two equations. These two equations, okay. Now, what we're gonna do is take a look at it and try to explore this guy. So si Maxwell, again, addict na siya sa math, in-explore niya tong Maxwell's equation dahil Maxwell's equation nga, di ba? So siya yung nag-explore nitong mga equations na to. Okay? So, wait lang. Hindi ko lang notes ko. Okay, now let's try to get the curl of a curl. The second derivative. What happens when we get del cross E, del cross E. Okay? So del cross E is actually madali lang kasi may product rule ka na sa likod ng libro mo. Okay? And that would be the gradient of the divergence. Gradient of the divergence minus the Laplacian of the field. Okay. Laplacian of the field. This is very nice. Okay. Now, I know my del cross E to be this guy. Tama? Del cross E is just a partial of B with respect to, so lagyan ko negative. And this would be partial of B with respect to partial of T. And then, the first term is just the gradient of the divergence ng E. 0. Di ba? Conveniently, 0 to. 0 minus del squared E. Okay? And then, what else can we get? Let's, ipapasok natin yung curl dahil again, this is a geometric differentiation and this is a time differentiation. So I can do that. Del cross B. I know this. And then the right-hand side would still be the Laplacian. Del cross B is the curl of B is this guy. Since wala tayong current in vacuum, we will just use this definition. And cancel ko na yung negative signs, no? Cancel ko na yung negative signs kasi parehas naman may negative. So the partial of T, plug in ko yung mu naught, epsilon naught, partial of T, partial of T. Del cross E. The Laplacian of E. Okay? So we have this, and then I could further simplify this kasi second derivative with respect to time lang yan. So this turns out to be the Laplacian of E, mu naught, epsilon naught, the second derivative with respect to time. We have this equation. Okay. Okay, nice. How about the other one? Kung gagawin naman natin siya sa the curl of B. Try natin. Let's pick another color. Del cross B. And we're just getting the cross din natin, curl din natin ng mu naught epsilon naught. Mu naught epsilon naught, and then partial T. Nirekta ko na. Pinasok ko na lang yung del cross E. Okay? Tama? Kasi ilang to, tapos i-curl ko. And then, the second, I know that the second derivative, second curl, is just this guy again. Kanina lang, inulit ko lang, minus the Laplacian of B. Okay, and the right-hand side, epsilon naught. What is del cross E? Del cross E is just the negative partial of B with respect to time. Negative partial of B with respect to time. And then the curl. Nakalimutan ko yung curl. Curl of the negative of partial with respect to B. Okay. Del dot B is just simply 0. Nice. And we're left with the Laplacian on the left-hand side. On the right-hand side, may negative sign ulit. Labas ko na yan. Pampagulo na lang yan. Tapos partial of T. Then del cross B inside. Okay. Then del cross B, I know that to be... Ay, mali ginawa ko. Okay, sorry. Anong ginagawa ko, sir? Nalito. Nalito ako design. Okay. Partial with respect to t. Ba't may natira pang ano? No? May natira pang curl. So, the derivative with respect to time of del cross E is just this one. So, negative partial B, partial T. Okay, and then scrap this. Yung negative sign, may negative sign pa rin naman. I left it outside, and then this becomes a second derivative with respect to B. Oh, okay, so the Laplacian of B becomes mu naught epsilon naught, the second derivative with respect to time of the magnetic field. And if we're gonna look at the electric field, oh, very similar. You have this, the Laplacian, in the left-hand side, Laplacian on the left-hand side. Sa kanan, meron kang second derivative with respect to time of B and of E. Oh. So, sobrang nagulat si Maxwell dito kasi I know this form of equations. This form of equation are waves. So, whenever you have a wave, del squared of f, whatever that is, green na lang, copy. Del squared of f, it must be a wave with a speed v running through time as this. So whenever you have a wave f, alam mo na yung equation that governing that wave would be given by this equation. Okay? So the left-hand side is a Laplacian. So this is an acceleration with respect to geometry. Okay. How it changes yung slope, how it changes yung slope ng function mo, and on the right-hand side would be how the wave would change in time. So this guy is a wave. Okay, so alam ni Maxwell to, nagulat siya. Okay, so yung E ko at B ko, there are actually waves. And if we're gonna pattern them down here, mu naught, epsilon naught, mu naught, epsilon naught. And then have these guys here down. B. Ayan. Okay, so kinopya ko lang yung kanina. So these are all vectors. It wouldn't make sense if hindi sila vectors. And what did Maxwell see? Yung E mo at B mo, they have the same speed, which is given by 1 over V squared. 1 over V squared must be equal to mu naught epsilon naught. And if we're gonna extract the velocity of these waves, V squared is just 1 over mu naught epsilon naught. Ay, sorry. Square root ko agad. And you have the velocity of these waves to be square root of these guys. Okay? So, PJ, nandiyan ka pa ba, PJ? Okay, mukhang wala na si PJ dito. Okay lang yan. Ross, ikaw na lang, Ross. Ayaw mo naman to. Paki-calculate naman sa calculator to. Merong constants na yung calculator ready na to for your scientific calculator. Ano yung value nito?
Wait lang, sir.
Okay. Okay, sige, Joshua. Nandito si Joshua. Joshua, ano yung value nito? Exact value.
Sir, parang may nakita lang po akong similar. Parang speed of light po ba?
Okay. This is, of course, the speed of light. This is 2.99 times 10 to the 8 meters per second squared. Meters per second kasi velocity. Tama ba? 6 digits from the right. Okay. So around 300,000, 300 million meters per second. Okay. So gulat na gulat si Maxwell dito na the electric field and the magnetic field, they are waving in your space with velocity. This guy. It's very, very, very fast. And naalala niyo si Faraday, that Faraday was experimenting with light and electricity. Tapos nakita ni Maxwell na kapag pinadaan yung light sa isang setup wherein there's a electric field and magnetic field, nagbabago yung light. Naisip ni Maxwell noon, oh my gosh, ito yung speed of light. Okay? So sila yung ibang mga nauna nating scientists, di nila makalculate yung speed of light. Okay? So si Maxwell biglang boom. Wala siyang experimental setup. Meron lang siyang notebook na calculating all of this in his mind. So nakuha niya na ito yung speed of light. And then syempre gulat na gulat siya, tuwang-tuwa siya. Binigay niya lahat tong experiment niya kay Faraday. Okay, kasi si Faraday talaga yung experiment dito. Tapos si Faraday be like, sino ka? Sino ka? Kasi ulyanin na si Faraday. Okay. Tapos sabi ni Maxwell, ito na yung speed of light na galing pala yung light natin sa electric field at magnetic field. Tapos hindi rin maalala ni Faraday na ginawa niya yung mga electric field at magnetic field experiments niya dahil nag-iulyanin na nga siya. Ayan. So we have that thing. So ito ay pahapyaw na rin sa chapter 9. No? So nilagay ko lang dito para may closure. Masarap kasi sa pakiramdam pag dito pala galing yung light. Okay, so you have that speed of light. Very nice. Okay. So ayun pala, pag yung meron kang electric field and magnetic field that is waving in vacuum, they probably came from a source that produces light. Okay? So syempre, hindi naman lagi na ayun talaga yung speed niya. It can slow down, of course, but it cannot exceed the speed of light. Okay? Can slow down. Kuwari nasa medium siya, mas mabagal yung light na. And kapag kinalculate mo yung wave equation for the electric field and the magnetic field, you'll get a different result, which is mu epsilon. Okay? Depende sa material mo. And that would mean that the speed of light in that material also changes. Okay? Meron tayong experiments na nagpapabagal ng speed of light into 1 meter per second. Okay, so pag pinadaan mo yung light sa isang Bose-Einstein condensate, which is a very, very, very cold material, bumabagal dun yung light. It acts as a particle. Amazing. So quantum na to. Sorry. I get carried. And then you have your problem set. You have these 3 questions. Madali lang yung unang dalawa. Actually, madali silang 3. So yung kailangan kong makita is yung explanation niya. Okay, so ito parang 3 lines of equation lang to. 3 lines of equation lang to. So you have to explain things to me, okay? Para makakuha ng full points. Okay, ito kasi ay transformer. Pag meron kang dalawang coil ng material, you can actually help the other loop to produce an EMF. So ito yung transformer mo. Okay. So, itong mga transformer natin, nakikita natin yung sa power lines natin para hindi masunog yung mga bahay natin. Okay. Pinapahina nung transformer, yung incoming EMF, para suitable siya sa gamit natin sa bahay. Kasi di ba, when you're farther from the source of the electricity, humihina siya. And then, kapag malapit ka dun sa source of electricity, sa power grid, malakas na malakas yan. So, hindi naman pwedeng yung buong puwersa nung dumaan sa bahay mo, susunog bahay mo, di ba? So, papahinain niya. Okay? Then this is a Lenz's law na experiment. Tapos this is a displacement current na problem. Okay, so madali lang yung tatlong yun. I just want you to experience yung mutual inductance and then, or basta induction. And induction din to. Pero Lenz's law more of Lenz's law to para alam niyo yung directions ng mga induced EMF. And then of course the JD, yung displacement current. Okay? So, hindi pa tayo tapos. Tapusin ko na yung chapter 8. Ito yung chapter 8. Itong slides lang na siya. Okay. Sa chapter 8 kasi, ang dalawang topic lang kukunin natin, which is yung Poynting theorem and the continuity equation. Yung continuity equation, reading assignment na yan. Pero na-discuss ko naman na yung continuity equation. Continuity equation. Okay? Kung di lang kayo convinced, pwede nyo basahin yun sa chapter 8. Okay, now we have your Poynting's theorem. Okay, so we recall that the energy due to the electric field is given by this guy, WE. Okay, so okay, so we have these two equations. You electric electric energy would be the integral of E squared, and then the magnetic energy would be the integral of B squared. Very straightforward. This was the things that we have calculated in the past few lessons. Okay? However, let's take a look at U. Itong U. U is the total energy per volume. Okay? Per total volume. Okay? So, ibig sabihin lang, hindi natin i-integrate to with respect to the volume and we get the total. Okay? So, you have this expression na pinagsama lang to pero hindi in-integrate with respect to the volume. So, you have your total energy per volume. Now, ang gusto natin makita is that yung paano ba natin yung ika-calculate yung work whenever we move things, we move charges. Okay, whenever we move charges in or move currents in your system. Di ba kasi ang diniscuss natin sa electrodynamics, when we move these things, meron ka na po-produce na electric field and magnetic field. Okay? So you have your F.dl, which is yung precisely yung work mo, di ba? And then F, we know that to be Q, E plus V cross P. Okay, from the very first mga lessons natin, ito yung mga forces due to DL. Okay? I can express DL as velocity. I just need it to be a... So, ito pwede ko siyang gawin na kasi ang tawag dito. I could express dx dt as okay, paano ba ito? So, si DL ay isang distance quantity. Okay? And whenever you have a V, dt, this is a velocity. So, yung velocity mo is dx over dt. Tapos dt. So, this is actually dx or dl in our problem. Okay, so I write that down. So, dotted with V. dt. Okay, convinced ba na dl din yun? Okay. And then, I could join q with that quantity qv dt. Okay, in general, I could write this as a j. Okay, current. And then yung del cross B is something that is perpendicular to your V and your B. Therefore, yung dot product nito with V is 0. So yung first term na lang yung mabubuhay. So we have your E dotted with J. Okay? So ito ay pwedeng I na lang or ano yung expression for basta tawag dito. Pag generalize ko to into a much larger Q, magiging J siya. Okay? So you have this dt. And this is work. dw. So okay. So you have your sorry. So this is the work for force, and then if we're gonna du siya. Okay? Para maging dw over dt, so divide ko by dt, no? Ito ay magiging integral ng e dot j dito. Okay? Okay. So, nagets bakit du lang to? Kasi ito ay force dahil lang sa isang charge. Kung bubuuin mo yung charge, kailangan mo integrate. Ito ay w. Okay. Integrate with respect to all volume. Okay, okay. Clear pa naman sa lahat? Now, I would want e dot j to be expanded further. So, j is gamitin natin yung del cross B. Ampere's law tayo. Ampere's law, mu naught J plus mu naught epsilon naught partial of E, partial of T. Okay? And then J would be del cross B over mu naught. Rearrange ko lang to. And then minus epsilon naught partial of E, partial of T. Okay? So, I plug in this thing there sa E dot J. So, alam ko na yung E dot J ko would be this guy. The dot product ko lang siya with E. Okay. It's just E dotted with del cross B over mu naught. 1 over mu naught. Tapos, the other one, E dot partial of E, partial of T. Okay. Ayan. The second term is easy. Pwede natin siyang i-express as express as pwede natin itong isulat as epsilon naught derivative with e squared. Okay? So, divide lang natin 2 by 2. Okay? Gets ba kung bakit naging ganito? Okay? So, e squared ay e dot e. Diba? Tapos kung derivative mo to, bababa lang yung 2. Cancel dito mo, babalik ka dito. Okay? Okay. So, kung di kayo convinced, i-try nyo by yourself. Now, what's left for us to work on is this problematic term. However, meron tayong product rule. So, we have that E dot curl of B. E dot curl of B. So, meron tayong term na to. So, E dot curl of B is just, okay, ito, lipat-lipat ko lang yung mga terms, no? So, we have del dot E cross B. Okay. Ang meron pala tayo ay B dotted with del cross E. And then minus this term, del dot E cross T. E cross T. Okay? So, del cross E, gamitin natin yung Faraday's law, is just partial of T with respect to B. Tama ba? Okay? And then, alam ko na pwede ko again isulat to as yung kanina. Na magiging 1/2 na lang siya nung derivative ng B squared. Okay? So, we have these terms that we could input now to our integral. Okay? So, that in the integral of E dot J, ay, may mu naught pa pala. No, nakalimutan ko yung mu naught. Okay. So, yung E dot J mo, okay. E dot J muna tayo para hindi tayo maguluhan. E dot J will be, plug in ko tong thing na to. Okay? Plug in ko tong thing na to doon. So, 1 over mu naught yan, is just negative 1/2. So, partial of T B squared, tapos plus del dot E cross B. Del dot E cross B. And then, we have an extra term. Ito, epsilon naught squared, epsilon naught over 2, sorry. Epsilon over partial T, E squared. Okay. Okay. Nicely enough, alam natin tong dalawang term. Oh, sorry. Nicely enough, alam natin tong dalawang term na to. Ito, unang term at pangatlong term to be your U. Okay? We have that U. Therefore, we can simplify now the things we have. So, dW over dt is that E dot J. Okay? E dot J, kinompute natin as this guy. Nakuha na natin tong first term. So, kapag pinagsama-sama mo lahat sila, we would actually get this term. Okay? So, nakita natin to, nakuha natin to. Derivative with respect to time, ayun siya, nasa labas. And then, yung isang term would be del dot E cross B. So, saan napunta yun? Del dot E cross B. So, the divergence of E cross B evaluated at the integral of volume. And that is the divergence theorem. So, pwede ko siyang isulat as this guy. Divergence theorem lang yun. Okay? So, we know this to be U. And now we can write this down as S. S.dA. S would be your Poynting vector. Okay? So, S will be 1 over mu naught E cross B. And this is the energy flux density. Okay? Kung i-revert back mo siya sa integral niya with respect to a volume, we can see that meron continuity equation para dun sa energy mo. Okay? So, this is your equation sa Poynting theorem mo. And if yung wala kang minumove na charges or you're in the region of space na walang charges, wala kang minumove, wala kang in-effortan, this would be 0. And you'd see that mabubuo mo tong expression na to. Which is very nice kasi kamukha siya ng continuity equation. So whenever your total charge per volume changes in time, yung flux density mo, energy flux density mo, changes accordingly. Okay? So, last na. Ito na. Example na lang para ma-appreciate nyo itong vector na to is when, okay, example 8.1, meron tayong current na may sa wire. Siyempre, may work done. Okay, which is just the heating of the wire. So, kapag may wire ka, pinadaan mo yung kuryente, iniinit yung wire. Tama ba? So, kunin natin yung electric field dun sa loob ng wire, which is just constant, okay? Alam natin yun sa unang example natin yun, na whenever you have, pag kinabitan mo na potential yung one side on the other side of the wire, magkakaroon ka ng potential difference, which is just V is equal to E dot PL, and E is just constant along that wire. So the integral DL is just L. So you have V equals EL. So ito yun. Okay, so the magnetic field is, of course, we know this. At the radius A, dun sa radius ng wire, it would be simply mu naught I over 2 pi S, pero S is equal to A, so we have this expression. Okay? Okay. So let's try to draw this. Okay. E is in this direction. Okay. And B is running circumferential. Okay, circumferential. This is B. This is E. Okay. Tapos, kunin natin yung Poynting vector S, which is just 1 over mu naught E cross B. Galing na to. Okay. Is E always perpendicular with B? Okay, kasi circumferential si B, then kung isipin natin si E ay pointing to Z hat, and B is in the phi hat, yes, then yes. So yung E cross B would be just Z hat cross phi hat, and we know this to be S hat. Okay? So, nasolve na natin yung problem na direction, S hat, mu naught. Nakalito pala. Kasi may S kang capital, saka may S kang small. So, ibig sabihin lang nito ay radial siya. Okay? Yung S na normal, usual coordinate natin sa cylindrical. And now we just get the E cross B. So, we just multiply E, B. Okay? E, ano yung E natin? V over L. V over L times mu naught. And then I over 2 pi A squared. Okay. So we have this. This is your Poynting vector. Okay? That is your Poynting vector. So simplify lang natin further. Magka-cancel kunin lang muna natin yung magnitude para cute. Kaka-cancel si mu naught, and then VI over 2 pi A squared L. Ay, 2 pi A lang pala. Sorry. At A squared nilalagay ko. Okay. Sorry. Okay. Carried away ako dun. So, ano yung Poynting theorem natin? Kunin natin tong energy na to. Ano to, guys? Yung left hand side. Power to, di ba? Change in work per time is power. So, kunin natin tong right term. So, S dot dA. Pili tayo ng dA to be the the cylinder, nagra-wrap cylinder na to. Kasi alam natin na yung pointing vector mo is radially outward. Yes. Okay? So yung dA mo would be this cylinder. Diba, i-wrap natin itong cylinder. Yung dA mo. And of course, yung S.dA, integral na S.dA is very simple kasi alam mo na yung dA mo is radial din, di ba? Yung surface na ganito, yung cylindrical surface, di ba, ang vector nun, normal din, which is radial din. So therefore, this multiplication is very simple. S times A na lang. So, yung magnitude lang muna kunin natin. SA. And A would be the cylinder. That's coating that wire. So we have A to be 2 pi A times the length covered. Okay, so plug in ko yung S ko. VI over 2 pi AL. VI over 2 pi AL times 2 pi AL. Cancel, cancel. What do we get? This is your power, di ba? Approximately equal to the power. Okay, so the power that is leaking dun sa surface mo is VI. Precisely kung ano yung alam natin in currents. So yung heat na yon is VI. Okay? Amazing, di ba? Whenever you have a circuit, kukunin mo yung power radiated by that circuit, yung heat na binubuga nun, that is VI. Okay, that's all for today. Again, meron kayong prob set. Thank you very much for staying. Let's continue chapter 9 on Tuesday. Okay. Chapter 9, kasama yun sa exam. And chapter 9 would be focusing on electromagnetic waves. Okay, thank you very much. Class dismissed. Sorry po sa... Kailan due yung prob set? Friday next week, before exam. Para matesting niyo yung mga problems. Okay? Okay. Sige, class dismissed. Thank you. Sorry, extend tayo. Excited ako dun sa P is equal to VI. Bye, guys!